Hello everyone and welcome back again. In the previous video, I explained how to add the subtraction operation to this circuit, but I didn't implement the hardware. I just explained the theoretical part. And as we see, we have the ALU, the arithmetic and logic unit, and this is our ALU. It takes two values, A and B, and each has 4 bits. A and B each has 4 bits as you see here on the red wires and on the green wires. But the difference between this theoretical part and the hardware part is the registers. Here we do not connect the bus directly to the ALU. We do this through R1 and R2. If you remember, through R1 and R2. Here in the theoretical part, we connected A and B directly to the ALU. That is not correct. So I'm going to fix this today. So we need to connect this to R1, 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 and this is R2, 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 right? So what we need to do now is, if we have registers here, so we need to connect the XORs to the registers themselves. You might wonder now, what if we need B minus A, not A minus B? What should we do in this circuit? That is very easy. Instead of saying subtract A, B, C, which means A minus B, and put the result in C, you will write your assembly like this, B, A, C. That is how it works. And that is how the software is related to the hardware, right? So that means that the B value, it will be the positive value here. And the A value will be the values that will be will pass through the 2's complement steps. Anyway, I hope that you understand all of this. What we need to do now is to implement the hardware of this circuit. How can we implement the hardware of this circuit? You can see that we need 4 XOR circuits, gates, and we have here this IC, the XOR LS86, and this IC has 4 XOR gates as you see here, and we need to understand how this connection will work. Okay, so let me see if we have another graph here, the same one. Anyway, so we have here R1 and R2. I am going to put the XOR gates to R2. So this is the XOR gates will be connected to R2. But R1 or A1 or A will be exactly the same. That's why if you look at R1, it is connected to the bus and from the bus to the ALU directly. But for R2, there were like 4 wires here, but I removed them. So these wires were connecting R2 to the bus here, and it takes the register output to the ALU. But I removed these 4 wires, and that means that this register is connected to nothing. It is not connected to anything, to the bus or the switches or anything. Why I am doing this? Because I want this register to take the values here from the output of the XOR gates. So this is our XOR. The XOR will take B0, B1, B2, B3 from the bus, and it is gonna provide the output to the register. So B0, B1, B2, B3 will be from the bus, and the output of the XOR gates will be connected to the register. So that's what we need to do. So this is our XOR gate. Let me show you the IC number. I hope that you can see this IC number. Okay, so what we need to do is connect first the VCC and the ground. Pin number 7 to the ground. Where is pin number 7? So this is pin number 1, pin 2, 3 up to 7, and you can see pin 7 is connected to the ground. Okay, and then let me zoom in a little bit. And then pin number 14 to the VCC. So this is this is pin 1, 7, 8, 14 to the VCC. And then we need to do this connection. Do you see these connections? So we have one line. This line is connected to the first bit of this XOR gate, the first bit of this one, the first bit of this one, and the first bit of this one. So we need to connect the first bit of all gates together to one pin. And that's what I'm going to do. Look at the first pin of this logic gate. It is pin number, let's say pin number 2. If you look at pin number 2, you can see that it is connected to this IC. And this should be connected to pin 5 here, because we are going to take the second pin here, and the second pin here, and the second pin here, and the second pin here. So 2 should be connected to 5. And I did this by this line, by this wire, from 2 to 5. And then on the other side, I am going to connect from 9 to 12. Do you see this? From 9 to 12, that's it. But this is not enough, because I connected these two pins together, and these two pins together. But these two pins and these two pins should be connected together, right? So that's what I'm going to do. I'm going to do like a wire, like a bridge here between this and this. Yeah. So now pin 2, pin 5, pin 9, pin 12 are connected together, and they are representing this value. I know that I didn't connect yet the carry in. I'm going to connect the carry in, but until now I didn't connect the carry in. But at least, do you see this wire? Yeah, this wire here, 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 here is finished. So let's now start connecting B0 only. So B0 will be from the bus to this pin in the XOR. So let's bring the bus here, first pin from the bus here, yeah, to pin number, let's go to this side. Okay, this is a short wire. Let's take this one. Okay, so okay, I think these wires are not for this side. Yeah, I'm just making sure that we have the correct wires. Okay, so I'm going to connect this to the first pin here. Okay, and then now I finished this one. I'm going to the second one. So the second pin in the bus, to this gate here. So this is the second pin. This is not correct. So I'm going to connect this here to the second pin. And this second pin should be connected to pin number, pin number, it should be the input. Let me check that. So this should be B0, should be B1, so it should be to pin number 4. This pin number 4, 0, 1, 2, sorry, 1, 2, 3, it should be to pin number 4. This is not correct. Okay. Let's go to pin number 10. Do you see? This is pin number 10. This is B3, right? So for B3, I am going to bring a wire from here to the third line here, this third line here, to pin number, let's see, pin number, it should be to pin number 10, right? So this is a short wire, so I'm going to connect a longer one. To pin number 8, 9, 10. Okay, and then this is B3 and this is B4 to pin number 13. So I'm going to bring this one to pin number 13. Okay, I hope that this is clear for you. So now we finished this wire, right? And B0, B1, B2, B3. We need to take the output of the XOR gates and connect it to the register. So we finished from the bus to the XOR gates. We need to take the outputs of the gates from here to the register. So how can we do that? Let's start with the first one. So the output here of the first gate should be connected to bit 0 in the register. And let me show you the register again. Yeah, this is our register, and the bit 0 should be at pin number 5. Bit 0, bit 1, bit 2, bit 3. We discussed this many times. It has nothing to do with P3, P2, P1, B0. We are talking about B0, B1, B2, B3, because the bit weights starts from right to left. So let's start with this value. The output of this one should be connected to pin number 5. So which pin of the XOR gate IC this output represented by? So if you look at the logic gates, so we are talking about pin number 3. So I am going to come here to pin number 3. Where are these wires? 1 second. Yeah, pin number 3. Let me see if this works. Yeah, so this is pin number 3 to pin number 5. 1, 2, 3, 4, 5. Okay, and then we need the second output to pin number 6 in the register. So the second output is pin number 6 here. This is not correct. So the second output, where are the wires? Okay, so the second one is pin number 6 from here to the next pin here. Okay, and then pin number 8 from here to the next pin in the register. So I'm going to take pin number 8 here to the next pin in the register, and then the next pin in the register here should be connected to pin number 11. So I'm going to connect this to pin number 11. 8, 9, 10, 11. That is really good. So we finished these connections, this one, this one, this one, this one. You might ask, we didn't connect anything to the ALU, right? No, the answer is we connected from here to here, and these values, 4 values, are connected to the ALU by the other side, by the second side. Anyway, what else do we need to? Yeah, we need to connect the carry in. Do you see the carry in? Okay, so we need to see which pin is the carry in for the ALU IC. That means we need to look at the ALU datasheet. Do you see pin number 13? This is, yes, this is the carry in. I know it is called C0, but this is the carry in and this is the carry out. So we need to take a pin from 13 in the ALU and connect it to this pin here, this pin. Do you know where is this pin? This pin is the intersect between this and this and this and this, right? So we need to remember which pin or which point is representing these connections, because the intersection is pin number 1. So if you look at this bridge, do you see this brown wire, this green one, the bridge here, and this brown one? All of these are the same point, if you remember. So I am going to take one connection from them here, okay, and put this on pin number 13 on this side. So I'm going to take pin number 13. So this is, let me see which pin is this. So this is pin number 9. I'm going to count here 9, 10, 11, 12, 13. So this is 13. So now we finished this one, right? What else do we need to do? Is there anything else? I think no. We can test now and we will see if there is any error or problem. So let's zoom out. And then I'm going to connect the power supply. Yeah, let's start with all zeros. Oh yeah, there is only one pin. Let me see the carry in. We connected this value and all of these pins, but we didn't connect them to either 1 or 0. So they are going to be, this pin is going to be considered as 1 because we didn't take this pin and connect it to the power supply or to the ground. So we have to take another wire from here and connect this wire to either the ground or the VCC. Or we can do this by a switch, but anyway, I don't need a switch now. So I'm going to take another connection from the same 5 point here, 5 points here, and I'm going to connect this to the ground. And again, I'm going to do like this. They all are zeros. So the zeros here, and I'm going to click here to trigger this register, so the values are zeros. I'm going to click here to trigger this register, so the outputs are zeros. Let's take this pin and connect it to the VCC instead of the ground. So this should be to the VCC. Why? Because if you put here 1, you are doing subtraction. So the values that will be output from the registers should be the 2's complement. So I'm going to put here 1. So we should see here the 2's complement, not the 0 values. Here we are seeing the 0 values because it is connected to the ground now. So I'm going to do this, okay? And then let's trigger this register, so they all are 1s. Why? Let me try this. I don't remember, but let me try it. So, yeah. So we have 0, 0, 0, 0. Let's take the 1's complement. So it is going to be 1, 1, 1, 1. So this is the first complement. So it should be plus 1. So 0. Here 1. So it should be 0, 1, 0, 1, 0, 1. It should be 4 zeros, and we should have like another bit here. Why they all are 1s? This is a question. Yeah, that is expected because the output of the register is not the final value here. It is just this value. If you remember, the output of the gates is not the 2's complement, but it is the negation. It is the first complement. And we add the Cn value equal to 1 in order to take the first complement and convert it to the second complement or the 2's complement. So the output of the register should be the first complement. So if we, for example, make like this, all are 1s, and then do this, as you see, all are zeros now as output from the register. And then if we only take this one, the first one here, as you see, they all 1s except the first one, because this is the negation of these values are the negation of these values, are negated by from these values. Okay, so now let's do the addition to make sure that the addition in this circuit is working fine, and then do subtraction. So I'm going to move this to the ground to do addition and try to do everything from scratch. So 0 plus 0 is equal to 0. 1 plus 0 is equal to 1. 1 plus 1 is equal to 2. these are 3, right? This value is 3, right? So 3 plus 1 is equal to 4. 3 plus 3 is equal to 6. 4, 2, 1, 2, 4. So 2 plus 4 is equal to 6. So the addition is working fine. Let's now move this to the VCC, and now we should see the output of the subtraction. So I'm going to start again 0 and 0. So this value is negative 0, right? So as you see here, 0 minus 0, it is 0 because this is the carry out, right? So we can see that this is, the carry out is on because this is like the negative 0. I know that there is positive and negative zeros, but this is how it is represented by the 2's complement. Now let's do this 1 and just do this as 1. What can you see here? We are saying 1 minus 0, right? So this is 0, right? So 1 minus 0 is equal to 1. Let's do 2. 2 for A. I'm talking about A now. So 2 minus 0 is equal to 2. Let's do 3. 3 minus 0 is equal to 3. So now let's add values for this one. So I'm going to say let's do this as 0, and then let's start here adding minus 1. So this is gonna be minus 1. Okay, so 0 minus 1 is equal to these values. I need to show you why we have this output, but we know that this should be minus 1, right? Because 0 minus 1 is equal to minus 1. So let me show you. We are saying 0 for A and B is equal to 1, right? But we need minus. So I'm going to calculate the 2's complement of A. So the 2's complement, we start with the first complement, so 0, 1, 1, 1, and then we add 1. By the way, if you look at this, 0, 1, 1, 1, okay? 0, 1, 1, 1. And we add 1 that comes from here to here, the carry n. So it is going to be 1, 1, 1, 1. Do you see the output? 1, 1, 1, 1. I hope that you understand this. Let me try with another value, and I think that will be enough. So this value is 3. So let's say 0 minus 3. It should be this value. Let's try again here. So 0 for A, and B is equal to 3, 1, 1, 0, 0. But we need minus. So I am going to calculate the first complement here, 0, 0, 1, 1. Add 1, it should be 1, 0, 1, 1. Do you see this? 1, 0, 1, 1. Let's try something different. Let's try 3 here. And let's try, let's say 7 here. So 7 here, it should be like this. So let's calculate this. A is equal to 3, 1, 1, 0, 0. B is equal to 7. So let's convert this to the 2's complement. So it is gonna be 0, 0, 0, 1 plus 1. So the value will be 1, 0, 0, 1. So this is minus B. We need to add A. So A is equal to 1, 1, 0, 0. So the value is 0, and we have 1 here. 0, we have 1 here. 1, 1. So do you see? 0, 0, 1, 1. So I think we finished the subtraction circuit, but I just want to mention here that this control pin that controls the operation to be either subtraction or addition will be controlled later by the control unit of the CPU. Do you remember this image, this picture? We finished this part, but we have a unit here called the control unit. The unit that controls the operations of each one of these units here. And you see this red line. This red line is triggering the ALU, is controlling the ALU, is telling the ALU to execute a subtraction or addition, depending on the instruction register values. Because the instruction will be moved from the RAM through the bus here to the IR, and the IR will do some decoding, and the value of the output here will go to the decoder, and the decoder will look at the value, and it will understand if it is a subtraction or if it is addition. And from that, if it is addition, the decoder or the control unit will send 0 here to the ALU, 0 here to this pin. And if it is a subtraction, it will send 1 to this pin. I hope that you understand the whole picture of all of this, because without understanding the whole picture, you will feel like this is difficult to implement. But I am trying to implement every step so that you can do the same on your side. Okay, so I think that's enough for today, and see you in the next video. Bye.